So for 4.2, we're going to prove congruence. So we're going to talk about triangle congruence, and we're going to use two theorems. We're going to use the side, 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 and another theorem called the side, angle, side. And so basically, let me describe the side, side, side theorem. So we say, whoops. There we go. Whoops. Getting a little happy there. We'll do the side, side, side theorem. So if I take a side, and we'll do it just like they do it in the book. And then so that looks just like the book. All right, so now I copied this, and basically the side, side, side is simple. If I could prove that all three sides are congruent, in other words, we know that this is congruent to this, we know that this is congruent to this side, and then lastly we have this being congruent to this side, then the two triangles are the same. And so let's label this. We'll call this A, B, C, and then we'll call this D, E, F. Okay? And the postulate is this. It's if line segment AB is congruent to line segment what? DE. And line segment BC is congruent to what? EF. And line segment AC is congruent to DF. Yep, DF. Good. Okay, so now that is the first part of my statement, right? The second part of my statement is what?
Then it's congruent.
Then, yeah, then the two triangles are actually congruent. So then we would say then triangle ABC is congruent to triangle DEF. And so this right here is what we call the side, side, side postulate. Okay? And so that's side, side, side. So the SSS, side, side, side postulate. So that is the postulate. Now let's try using it in an example problem. Okay, do you guys have this all written down? Can I move on to
No.
Yeah.
Okay, I'll give you a second.
So, this whole thing right here, the AB is congruent to DE, that's the side, side, side.
Yeah, so yeah, let me rephrase it. She's saying, what is the side, side, side postulate? This whole thing right here. So what we got to do, remember that in our statements, if P is true, then it implies Q is true, right? So what we're saying is if this side, if these two corresponding sides are congruent, and these corresponding sides are congruent, and these corresponding sides are congruent, then the triangles are congruent, right? And to put that in regular terms, it's like if I could prove all three sides of two triangles are the same lengths, the corresponding sides are the same length, then I can prove, using this theorem or postulate, that both triangles are congruent. And remember, congruency means that they have the same measures, both the angle measures and the length measures, not just one or the other. Because you can have triangles that have the same angles, but different side lengths, and we would call those similar triangles, right?
And you can go straight from this to angles are congruent too, not just the triangle up top.
Yeah, you commit. Yeah, right. So that there might be a point in time in your homework where you're asked to prove that the angles are congruent, and if we know that the side lengths are congruent, then we can say that the triangles are congruent. And then you could, what she's saying is, could you infer like something like angle C is congruent to angle F? And the answer is yes. Yeah, good. All right, so let's do example number 1. So that was just a postulate. Let's do example number 1 using that postulate. So if I draw a figure, let's go through and pick one. Let's do a rectangle. Is that a real rectangle? I guess, yeah. So now if I draw a rectangle like this, and then I draw like a straight line through it, well, don't we know that this is this length? That those two lengths are congruent, right? That's the very definition of a rectangle, right? And don't we know that this length is congruent to this length? Now, and let's label this. Let's call this L, P, N, and M. What do we know about Ln? Is Ln equal to Ln? Is Ln equal to Ln? Because we have two triangles up there, right?
Are you saying N or N?
N, as in Nancy.
It is.
It is. So we could even say this kind of, right?
Because if the two sides are equal, then there can only be one possible answer.
So what they're saying is, in example number 1, what they're saying using side postulate, prove that triangle LMN is congruent to triangle NPL. And so what they're going to do is we're going to do like kind of like a flow chart, right? So, well, not a flow chart. Do we want to do a T proof or do we want to do a flow T? I like using the T ones too, so we'll do that. So remember here we have our statement.
I don't like any of them.
Yeah, I don't like any of the proofs. Is that what you're saying? Okay, just remember we're recording. And then the reason. All right, so what were the statements? Well, this one we inferred, but we knew this was given in the diagram, right? So I could say that Pn is congruent to what? LM.
ML.
M. Oh, good catch. Yeah, ML. Good. Do you guys know why she did that? It's because these are corresponding, right? So we want to kind of be careful. It really wouldn't have mattered either way, but it's good that we're keeping track of that. So that was given in the figure. The other thing that was given is that PL is congruent to PL is MN, right? Okay, so those were all given. So those are two. Now how do I prove the third side? Well, the third side is simple. I'm just going to say Ln is congruent to NL. I guess you could write it that way. And what property is that? Does anybody remember?
Reflexive.
Yeah, it's a reflexive property, right? The textbook writes it this way. It'd probably be better to write it this way for it to really be reflexive, right? But that's the reflexive property, right? All right, so now I could say, because I've proven that all three sides are congruent, I could say that triangle LMN is congruent to triangle NPL, and that's based on the side congruence postulate. Oh, that was a simple proof. We really only had to do one thing. Okay? Any questions on that? No? Okay, good.